Okay, your homework questions from over the weekend. These are from page 459. Question number 1 wants you to find the components A of a vector 16 meters at an angle of 75 degrees. So you draw your xy axis. Angle of 75 degrees would be in here. This is 16 meters. And finding the components means finding the x and y. So drop a line down. Here would be your x. Let's make that an x. Here would be your y. And here is your angle, 75 degrees. So you have the hypotenuse and you have the angle. And so you're looking for the opposite and the adjacent side. X is the adjacent side, which would be cos theta. So cos of 75 is equal to x over 16 meters. So x is equal to 16 meters cos of 75. And then punch the numbers in. Y is the opposite side, which would be sine. So sine of 75 is equal to y over 16 meters. So y is equal to 16 meters sine of 75. And then again, you're going to punch your numbers in. So 75 times, 16 times 75 cos. For x, you should get 4.141 meters. And for y, you should get 15.455 meters. For x, it's in the positive x direction. For y, that's in the positive y direction. Can't really say east or west and stuff because they didn't tell us that. They told us with respect to the xy coordinates. Okay, so for B, 8.1 meters per second squared at an angle of 145. So 145 is going to be over here. And this angle is 145, but obviously you need the reference angle. So you would take 145 away from 180, and the reference angle would be 35 degrees. Again, drop your perpendicular down. Here's your x, here's your y. You have to use the 35. You can't use 145 in sine and cos because how can you have a 145 degree angle in a right angle triangle? So again, x is the cosine. So cos of 35 is equal to x over 8.1 meters per second squared. Doesn't matter that it's acceleration. It's still a vector, so you do exactly the same thing. So 8.1 meters per second squared times the cos of 35 for x. And for y, it'll be sine of 35 is equal to y over 8.1 meters per second squared, or y equals 8.1 meters per second squared sine of 35. Again, you type these numbers in. So 8.1 times 35 cos, and you get 6.635, and that's meters per second squared, and this time that's in the negative x. And when you do y, 8.1 times sine of 35, you get 4.646 meters per second squared in the positive y. All right, the last one for number 1, it's at 225. So it's down here in the third quadrant. If this whole thing is 225, then that means the reference angle is 45. Here's my x, here's my y, this is 45. The good news is that sine and cos will be the same. So cos of 45 is equal to x over, what was this, 16 meters per second. So 16 meters per second. X is equal to 16 meters per second cos of 45. And y will be sine. So y over 16 meters per second, y is equal to 16 meters per second sine of 45. And I trust that you all know that sine and cos of 45 is the same, so that when you do this once, you get the answer for both of them. They both should be 11.314 meters per second. 11.314 meters per second. And then we look at direction. For x, it's negative x, and for y, it's negative y. Done. Okay, now for for number 2, they change things up just a little. And instead of giving it to you with respect to the xy axis, they're giving it to us with respect to east, north, south, west. Okay, so this time you're going to draw your vectors the way you learned in grade 11. Remember, the first one, the north, means you start off going north, and then you turn however many degrees it is in the direction of the second one. So for 2a, it's north 20 degrees east, which means you start off going north, and then you turn 20 degrees east. And then here is your resultant. So this is going to be 20 kilometers, and here where you began is your angle. And again, it wants you to find the x and y. So this time, when you take a look, notice that the x is the opposite this time. So it's going to be sine of 20 is equal to x over 20 kilometers. So x is going to equal 20 kilometers sine of 20. And y is going to be the cosine. So cos 20 is equal to y over 20 kilometers. So y is equal to 20 kilometers cos of 20. And then do the math. So 20 sine times 20. And you get x to be 6.84 kilometers. Look at the direction, that is east. Do the y, 20 cos times 20, y is equal to 18.79 kilometers, and that is north. For b, it's east 30 degrees south. So originally you're going east, and then you turn 30 degrees south. Here is my resultant. 3 meters per second. Here's my 30 degrees. X, y. This time y is back to sine. It's the opposite. X is again the adjacent. So it'll be cos of 30 is equal to x over 3 meters per second. X is equal to 3 meters per second cos of 30. Okay, and y will be sine. So sine 30 is equal to y over 3 meters per second. Y is equal to 3 meters per second sine of 30. This one we can do in our heads. It's 1.5 meters per second, and that's going to be south. This one, 8.66 times 3 is 2.598 meters per second, and that will be east. Last one in B. This time it's west, so we're going west. And I didn't draw it big enough. Sorry, I have to do it over here. West, and then north. Okay, and when I said big enough, I meant I didn't leave enough space. So here is my 70 degrees. This is my x, this is my y, this is 6.8 meters per second. X is going to be cosine again. So cos of 70 degrees is equal to x over 6.8 meters per second. X is going to equal 6.8 meters per second cos of 70. Y is sine, so sine of 70 is equal to, let's make that a y. Y over 6.8 meters per second. Y is equal to 6.8 meters per second sine of 70. And again, 6.8 times the cos of 70 gives you